Hello guys. My name is Maureen Alfonso M. Garcia, BSIT 2ABA. Good day everyone. My name is Maureen Alfonso M. Garcia, BSIT 2ABA. And this is my project from IT 226 to Sir Jess Lindo. So let's start. Energy technology. They are primary sources, take many forms including nuclear energy, fossils, energy like oil, coal, and natural gas, and renewable sources like solar, wind, geothermal, hydropower, and bioenergy. Energy technology is an interdisciplinary engineering science having to do with the efficient, safe, environmentally friendly, and economical extraction, conversion, transportation, storage, and use of energy target towards shielding high efficiency, risking skirting side effects on human, nature, and the environment. What do you mean by energy technology? Energy technology is concerned with developing systems capable of producing, transporting, and delivering energy in a way that is safe, economical, and increasingly environmentally friendly. What are some examples of energy technology? Renewable energy, solar power. Solar power, the conversion of energy from sunlight into electricity, either directly using photovoltaics, indirectly using concentrated solar power. Wind power. Wind power or wind energy is the use of wind to provide mechanical power through wind turbines to turn electric generators for electric powers. Geothermal. Ge- the word geothermal comes from the Greek words geo earth means earth, therm means heat. Geothermal energy is a renewable energy source because heat is continuously produced inside the earth. People use geothermal heat from bathing to heat building and to generate electricity. Hydropower. Hydropower is using water to power machinery or make electricity. When flowing water is captured and turned into electricity, it is called hydroelectric power or hydropower. There are several types of hydropower. Electric facilities. They are all powered by kinetic energy at flowing water as it moves downstream. Bioenergy. Bioenergy is the one of many diverse resources available to help meet our demand for energy. It is a form of renewable energy that is derived from recently living organic materials such as biomass, which can produce transportation fuels, heat, electricity, and products, enabling technologies. Solar energy. In 2015, three solar farms were constructed in the Philippines. The Philippines received for 70 kilometer watts per hour per square meter per day during its peak of April and lowest at 3 kilometer watts per hour per square meter per day during its peak of month of December as observed in 33 cities of the country. Given the country's high solar potential, the solar energy contribution to the energy mix is expected to increase from the current 2019 1.2 of 23 to at least 3.5% of the 43 total capacity by 2040. This is the picture of solar energy. So, the conversion of energy from sunlight into electricity, either directly using photovoltaics, indirectly using concentrated solar power. Wind energy. All wind power sites in the Philippines are onshore facilities, some such as Ilocos Norte, Pilila Wind Farm in Rizal, and Bangi Wind Farm are tourist destinations. The Philippines has significant wind energy resources spread across various islands of the country. As of 2019, the Philippines has installed onshore wind capacity of 426.9 milliwatts. These wind projects are expected to drive the onshore wind energy market during the forecast period. Yan, wind energy. Wind energy is the use of wind to provide mechanical power through wind turbines to turn electric generator for electric power. Geothermal energy. In the Philippines, geothermal energy is used to generate electricity. Two types of technologies are used in the Philippines. These are firstly, the higher temperature plus steam method, and secondly, the lower temperature binary cycle method. In the Philippines, the first is more common. The second is used only at the Macban plant. Geothermal plants are suitable for areas with low winds, such as Mindanao, and areas that have many rains weather, such as Batanes. Geothermal energy production can result in the release of toxic substances such as mercury, hydrogen, sulfide, arsenic, and selenium. In 2014, at the thermal plant in Biliran, 8 plant workers were hospitalized with hydrogen sulfide poisoning. Geothermal energy. Geothermal energy is renewable energy sources because heat is continuously produced inside the earth. People use geothermal heat for bathing, to heat building, and to generate electricity. Hydropower. In the Philippines, there are hydroelectric plants of both the conventional dam and run-of-the-river types. Of 29 hydraulic electric plants, 4 are conventional dam and 15 are run-of-the-river system. Many areas of the Philippines are suitable for hydroelectricity production. However, hydroelectricity production in the Philippines can cause upstream and downstream flooding during monsoonal weather and when excess water is released from dams. Non-dams. Hydroenergy. Hydropower is using water to power machinery or turn into electricity. It is called hydroelectric power or hydropower. There are several types of hydroelectric facilities. They are all powered by kinetic energy of flowing water as it moves downstream and makes electricity. Bioenergy. Biomass energy refers to energy derived from plants and animal sources. Biomass resources are abundant in the Philippines due to its large agricultural industry, whereas rice husk and coconut husk are used to generate power. The Philippines also uses biogas from landfill and biomass energy source. The availability of biomass can be affected by events such as drought. Biomass is the one of many diverse resources available to help meet our demand for energy. It is a form of renewable energy that is derived from recently living organic material known as biomass, which can use to produce transportation fuels, heat, electricity, and products. What are 11 alternative energy technologies? Hydrogen gas, tidal energy, biomass energy, wind energy, geothermal power, natural gas, biofuels, wave energy, hydroelectric energy, nuclear power, solar power. Why is energy technology important? Energy technologies are the primary determinants of energy availability, fuel choice, and use efficiency, and the degree of nature of byproduct emission, and energy research and development. It is the vehicle by which new technologies become available.
Software testing and quality assurance. What is software testing? Testing is the process of establishing confidence that a program or system does what it's supposed to. Testing is the process of executing a program or system with the intent of finding errors. Testing is any activity aimed at evaluating an attribute or capability of a program system, determine that it meets the required result. What is software testing? One of very important software development phases, a software process based on well-defined software quality, control and testing standard, testing methods, strategy, test criteria, and tools. Engineers perform all types of software testing activities to perform a software test process. The last quality checking point of software on its production line. Software testing is about testing a feature by applying test data to get a result and then comparing the actual result with expected result. It is not only finding the defect that is completely dedicated disciplinary of evaluating the quality. The process of the process or method of finding errors in a software application or program so that the application function according to the end user's requirements is called software testing. Who does testing? It depends on the process and associated stakeholders of the project. And in the IT industry, large companies have a team with the responsibility to evaluate the developed software in context of the given requirements. Moreover, developers also conduct testing, which is called unit testing. In most cases, the following professionals are involved in testing a system within their respective capacities: software tester, software developer, project lead manager, and user. Different companies have different designs for people who test software on the basis of their experience and knowledge, such as software tester, software quality assurance engineer, Q&A, QA analysis. It is not possible to test the software at any time during its cycle. The next two sections state when testing should be started when it ends during its SDLC. Testing Testing should be started as early as possible to reduce the cost and time to revert the produced software. It is bug-free so that it can be delivered to the client. However, in software development lifecycle (SDLC), testing can be started from the requirements gathering phase and continue till the software is out there in production. It also depends on the development model that is being used. In the waterfall model, testing starts from the testing phase, which is quite below in the tree. But in the V model, testing is performed parallel to development phase. Why testing important? Software testing is really required to point out the defects and errors that we made during the development phases. It's essential since it makes sure the customer reliability and their satisfaction in the application. It is very important to ensure the quality of the product delivered to the customer help in gaining their confidence. Testing is necessary in order to provide the facilities to the customer, like the delivery of high quality product of software application which requires lower maintenance cost and hence result into the more accurate. consist and reliable result. Testing is required for an effective performance of software application or products. It's software to ensure that the application should not result into any failures because it can be very expensive in future or in the later stages of development. It's required to stay in the business. Hmm, cut and cut. So, the importance of software testing is evident in the final quality assurance reports. By successful passing through the device diversified levels of testing. It's crucial, of course, to help treat, isolate, or hospitalize people who are infected. Testing also are important in the bigger public health. Positive early of cause of illness enables individuals to isolate themselves, reducing the chances. 7 principles of software testing. 1. Testing show presence of defects. Testing can show that defects are present but cannot prove the fact that there are no defects even after testing the application or product. Truth. We cannot say the product is 100% defect free. Number 2. Exhaust is testing is possible testing of every including or combinations of inputs are precondition. It is not possible, so instead of doing the exhaustive testing, we can use risks and priorities to focus testing efforts. Number 3. Early testing. In the software development cycle, testing activities should start as early as possible and should be focused on defined objectives. Defect clustering. A small number of modules contains most of the defects discovered during pre-release testing or show the most operational failures. Pesticide paradox. If the same kinds of tests are repeated again and again, eventually the same set of test cases will no longer able to find any new bugs to overcome this pesticide paradox. Testing is context depending. Testing is basically context independent. Different kinds of sites are tested differently. For example, safety critical software is tested differently from an e-commerce site. Absence of errors fallacy. Falsy. If the system is unusable and does not fulfill the user needs, and expecting an inspection that finding and fixing defects that not testing show presence of defects. Testing can show the defects. So ito number 1. Testing show presence of defects. Dito, tinetesting muna yung product kung may defects or para ma-prove na rin kung 100% pwede siya. Fundamental software testing. The 5 stages of fundamental testing. Test planning and control. Test analysis and design. Test implementation and execution. Evaluating exit criteria and reporting. Test closure activities. Test planning and control. Dito yung pagpaplano at pagsasagawa sa software testing. Sa test analysis and design. Sige. Search natin yan. Tuloy-tuloy ko na lang pasa. Phases of fundamental test process. Fix. Test planning control. Test analysis and design. Test implementation and execution. Evaluating exit criteria and reporting. Text closure. So, ito yun. Bale pa ulit-ulit lang to. Fundamental test process. 5 pesos. Fundamental test process. Ito yung process ng 5 phases of fundamental test process. Test planning and control. Test analysis and design. Test implementation and execution. Evaluating exit criteria and reporting. Test closure. Lahat ng to, lang, pa ulit-ulit lang. Yung fix, design, and repeat. Fix component and test cases, scripts, and repeat. Fix design and repeat. Fix component test plan and repeat. QA and QC testing. Testing quality assurance and quality control. Most people get confused when it comes to pin down the difference among quality assurance, quality control, and testing, although they are interrelated and to some extent they can be considered as same activities, but there exists distinguishing points that set them apart. The following a table is the points that differentiate QA, QC, and testing. QA, QC, and testing. Quality assurance. QA includes activities that ensure the implementation of process, procedures, and standards in context to verification of development software and intended requirements. Quality control. It includes activities that ensure the verification of our development software with respect to the documents. Testing. It includes the activities that ensure the identification of bugs, errors, defects in the software. Focuses on process and procedures rather than conducting actual testing on the system. Focus on actual testing by executing the software with an aim to identify bug defect through the implementation of procedure, and process. Focus on actual testing. Process-oriented activities. Product-oriented activities. Product-oriented activities. Preventive activities. It is corrective process. It is preventive process. It is subset of software test lifecycle. QC can be considered as the subset of quality assurance. Testing is a subset of software control. Software testing isostand. Some of the others are related to QA and testing process are mentioned below. IEEE 829 Test Documentation. IEEE 830 830 A guide for developing system requires specification. IEEE 730 A standard from software quality assurance plans. IEEE 1008 Unit testing. IEEE 12207 A standard for software lifecycle process and lifecycle data. PS 7925-1 Vocabulary of terms in software testing. PS 7925-2 Software component testing standard. Types of testing. This section describes the different types of testing that may be used to software during SDLC. Manual testing. Manual testing is include the testing of software manually without using any automated tool or script. In this type, the tester takes over the role of an end user and tests the software to identify an unexpected behavior or bug. There are different stages for manual testing, such as unit testing, integration testing, system testing, and user acceptance testing. Testers use test plans, test cases, or test scenarios to test a software to ensure the completeness of testing manual. Manual testing also includes exploratory testing as testers explore the software to identify errors in it. Automation testing, which is also known as automation, is when testers to write script and uses another software to test product. This process involves automation of a manual process. Automation testing is used to rerun test scenarios that were performed manually, quickly, and repeatedly. Software testing tools. The following tools can be used for the automation testing. HP Quick Test Professional, Selenium, IBM Rational Function Tester, Test, Test Complete, Test Anywhere, WinRunner, LoadRunner, Visual Studio Test Professional, WATIR. There are three types of testing. 1. White box testing. Unit testing, structural testing. Number 2. Black box testing. Functional testing, integration testing, system testing, usability testing, compatibility testing, configuration testing, concurrency testing, non-functional testing, security testing, automation testing, performance testing, load testing, stress testing, volume testing, and recovery testing. Documentation. This documentation includes a documentation of artifacts that should be developed before the during the testing of software. Documentation for software testing helps to estimating the testing process effort, required test coverage, requires tracking, tracing, this, and etc. This section describes some of the commonly used documented artifacts related of software testing such as test plan, test scenarios, test case, test traceability matrix, skill required to become a software tester, verbal and writing communication, passion, technical skill, analytical skill, attitude, productivity. So, overall, is a good software tester. Skill required to become a software tester. A good software tester should have sharp analytical skill. Analytical skill will help a break a complex software system into smaller units to gain a better understanding and create corresponding test cases. A good software tester must have a good verbal and written communication skill. Testing at times could be a demanding job, especially during the release of a code. A software tester must efficiently manage workload, have high productivity, exhibit optimal time management and organization skills. To be a good software tester, you must have a great attitude, an attitude to test to break, detailed orientation, willingness to learn and suggest process improvements. To excel in any profession or job, one must have a great degree of passion for it. A software tester must have passion for his or her field, but how do you determine whether you have passion for software testing if you have never tested before? Academic background. Academic background of a software tester should be a computer science, a BTech, BE, MCA, PCA, BASC. Computer will land you a job easily. If you do not hold any of these degrees, then you must have complete a software testing certification like ISTQB and CSTE, which help you to learn software development, life cycle, and other testing methodologies. Career option for software professionals. SS, SCM Manager. Security IS Auditor to IS Manager. So, ito no, meron dito tatlo na sa gitna. SCM Analysis, Test Engineer, Test Analysis. So, parang ano lang to, cycle lang. Yun lang. Career options for software professional. As mentioned above, for being test engineer, one can move to senior test engineer, test lead to test manager, else can become QA and QA manager. The options available in the testing tools site are enormous. There are numbers of functional performance security testing tools, site test management tools like Quality Center from HP, CQTM from IBM, etc. The demand from niche skills like SOA tester, security tester are on the increase. There are dearth of skill in test automation areas. Scripting skill in the tools language like VM, Java and the scripting language like Perl, Shell, Python, Shell Python, etc. Technical resources with capabilities to evaluate automation tools, create automation framework, and reusable components are on demand anyways. There is demand for good performance tester. You can analyze the performance test system, they identify the bottlenecks and suggestion. Turning technique. Software tester. Software tester salary. Ninja. The average fare for a software tester is Rs 310,575 per year. People is on the job generally don't have more than 10 years experience. Experience strongly influence salary for this job. The skill that increase pay for this job the most are test automation, test planning, and SQL. Software testers sa United States. A software tester earns an average salary of $55,000, 334 per year. Most people with this job move on to other position after 20 years in this career. The highest paying skill associated with this job are ASP, .NET, and .NET. Ito yung ano nila, salary bonus out profit sharing commission total pay $32,911 to $89,272. Career path of tester. The career path of tester. Then step by step. Step 1. Test evacuator. Executor pala. Curious, curious meticulous observer who executes test cases and reports bugs. Step 2. Test designer. Use the test design technique, critical analysis, and manage matrix. Step 3. Senior tester. Specialize in testing technique and business sectors such as finance and health, etc. Step 4. Technical tester. High specialized in the test the material performance and testing the security. Test manager organize and coordinates a test of management and matrix to establish strategies, plans, and information. Scope of testing. Software testing so professionals are huge demand both of India and abroad. India testing abroad has more than 30,000 certificate tests. International Software Testing Qualification Board (ISTQB) foundation level exam is globally accepted certification for some software testers. Software testing is more challenging domain. At the same time, it offers the lucrative salary package for talented professionals. Every day, hundreds of new software applications are launched in the market. As a result, there is a huge demand of software testers who can validate software products of various levels. According to a recent survey, India is going to be the popular software outsourcing destination in the world because of its operational efficiency and talented workforce. As a software tester, you can career advance will follow the following hierarchy: junior testing, senior test engineer, senior test engineer, team lead, project.